Hello, scholars. Welcome to another live CSEC class. Today we're going to look at trigonometry and the types of triangles. So trigonometry has to do with the study of triangles, the study of the different types of triangles, finding finding the unknown angles in a triangle, finding the sides of a triangle. All of that is trigonometry. So you have to know what are the different types of triangles so that you can manipulate the questions. If a question is asking you to find the missing side, it is triangle, then you will know find the missing sides. Likewise, if you know the type of triangle, then you will be able to find the missing. All right, so that's what we're going. So I'm going to screen. The first that we're going to look at is the acute. Hold on. Sorry. All right, is the right angle triangle. All right. So the right angle triangle. So we have. I can't draw straight lines with this. Pretend this is straight. So that's the right angle triangle. So it's a down, so straight, it's a vertical line, horizontal line, meeting each other, meet at right angles. So normally in math, when we have angle meeting at a right angle, we use a square, or some people would say a box, to other angles which we use a curve to denote where the angle is, right? So the right angle triangle, by looking, you can tell by looking for the box in there. And don't think that, so let me write the name. This is the right angled triangle. Don't think that the right angle triangle has to be turned that way. It can turn the other way, but these lines are straight. So it can turn that way. It can turn this. Right? It's just one single way it can look. Turn. I mean, you can orient it anyway. But the important thing, you have a straight line, a straight horizontal line, meet each other at right angles. They meet each other, they form a 90 degree. So if you were to take your protractor and measure that angle there, you would get 90 degrees. So a right angle triangle, 90 degree angle. The other two angles will vary. Sometimes they are. So for example, if that is 45 degrees, and this one is also 45 degrees, this is a special type of right angle triangle, right at these triangles. And in a little while, we'll tell you what triangle is. This is the right isosceles. has two equal angles of 45 degrees. That makes it isosceles, having the two equal angles. 90-degree angle that makes it right. So it's a right isosceles. But it can also be a right scalene. If all three angles, then it's a right scalene. So let's say this is 50 degrees. This one here is degrees. Right scalene. So the 90-degree makes it right, and since all three angles, so 50-degree angle of three angle. Bear in mind, three sides angles to 60 degrees, right? The angles must add up to 108. So if we know them, so if we know, or if we're just showing this box there, that's a 90-degree angle. And we're told the other one, we can find the missing one by adding the 90 and whatever the other one is you're given. So for example, if you're given this triangle, you're given this, and they said to you, find the missing angle. They said to you, this is 61. How much is this one? We know that all angles in a triangle, when you add them up, 180 degrees. That's fact. But saying then how they want this, and they will tell you this one. They don't tell you this, but you know this, because once you see the box, you know it's a right angle triangle, you know it's 90. So just add that 90 just add that 90 degree that you know, plus the 61 that you were also, so that would give 161 degrees. Subtract that from the 180, which everything must add up to 180 in the triangle. And that's to find the missing one. You'll notice 29 degrees. So, but you know it is 90 from it. So they tell you that it's a right angle triangle, whether they draw the box or not. If they say to you, it's a right angle triangle, you know that's a 90-degree angle. Next triangle is the equilateral triangle. Equilateral. Equi means equal, lateral side. So equilateral triangle, sides. And we indicate the equality of the sides by putting the same stroke across the side. So anytime you look, sides have the same strokes. They are equal. The equilateral triangle, since all the sides are equal and all the angles are equal, then each angle must be what? We have to divide it by 3 because it's 3 equal sides, angles. So each side must be 60 degrees. Each angle in the equilateral triangle is 60 degrees. So this is a really special triangle. 3 equal angles of 60 degrees each. So if, for example, let's tell you the perimeter of the equilateral is 21 centimeters. You can find the length of each side. 3 equal sides, you can just divide that 21 by 3 because it's 3 equal sides. So the equilateral, it has 3 60-degree angles. And once you know the length of one side, you automatically know the other sides, they are the same. So let's look now at the Isoceles triangle. Isosceles have 2 sides and angles that are equal, and 1 side and angle. So the 2 base angles are equal. Whatever this one is, that one is. And then this one will be different. Put strokes on these 2 sides so that they are equal to each other. Have 1 stroke to show that it's different from these 2. So we call these the base angles. 2 angles are the base angles. They are the same. Sides attached to the base angles are also. So in triangle, so you say put that and this one. So say this is 80 degrees. Yeah, 80 degrees. They're asking you, telling you anything in this one. Because these strokes tell you these 2 angles are the same. So this is 80. You can fill in 80 here. Even though they didn't give it to you, it must be the same because these 2 lines are the same. It's an isosceles triangle. You know this and this, 80 and 80. So you add the 2 angles that you know, 2 if you prefer. So that's 1 degrees. Since you know angles in a triangle are 80, so 1 minus 160. And that will give you 20 degrees. So this mix is equal to 20. So let's look at another type of triangle. And that one is called the scalene triangle. In the scalene triangle, we have 3 different sides, 3 different angles. They all still must add up to 100 degrees, but they are all different. The 3 angles are different. So 3 different sides, 3 different angles. So that angle will be different, which will be different from 3 different sides. 3 side might have 3 strokes. That side, because they're all different lengths in the scalene. I remember we said you can write scalene where you have a 90-degree angle and then 2 other angles. So for the scalene triangle, if you are told the length and of the sides, angle, if you are told this is 50 degrees and this is 70 degrees, how much is this one? Add the 50 and the 70, you get 120. Angles in a triangle add up to 180. So now you just take that 120, 180, and you're left with 60 degrees. So 50, 60, 70. Okay, one angle is 50 degrees, one is 60 degrees, one is 70 degrees. All right, we have more triangles to look at. We're going to look at the acute angle triangle and the obtuse angle triangle. The less than in the angle, all the angles are acute, or each of the angle is less than 90 degrees. They still almost add up to 180 degrees. So the triangle we just looked at, where we had a 50-degree, a 60-degree angle, a 70-degree angle, not drawn to scale. These angles is less than 90 degrees. So an acute angle triangle. Tell me some values. Tell me some values of a triangle. I want you to post the three angles of a that could be acute. That's what I want you to do for me now. Just write three angles. Write three angles for a triangle that would be an acute angle triangle. So I'm seeing 65, well, 65, 70, 50. Would those add up to give 180? We're saying that the triangle on the screen, 60, 70, those add up to 180. Good angle. So you can't have 65, 70, and 50. You haven't just 70 and 50. So you can't have 65. You would have to take off 5 of one of the others. So maybe 65, 65, and 50, or 65, 70, and 45, something like that. I'm not asking you to tell me how much they must add up to. I'm saying, tell me three different angles. Triangle could be an acute angle triangle. So in other words, you want three numbers that are each than 90 degrees, but they all add up to 180 degrees. All right, that's what we're looking for. The last triangle we're doing now is the angle triangle. Okay, that's the last one we look for this session. So the obtuse now an obtuse is greater than 90 degrees. Obtuse angle triangle has an angle that is greater than 90 degrees. So it's a wide angle. Have more than one, because that would make it that would make it no longer, because remember the angles in a triangle must add up to 180, right? So this big angle here is more than 90. Remember, the 90 would be like that. So inclined more than that, anything about more than the 90, that's an obtuse angle. So a triangle that has one angle that's more than 90 degrees, and the other two would be very small then. The other two angles would be, because everything must still add up to give 180 degrees. So the obtuse angle triangle has a wide angle for one of the angles, and then narrow angles for the other two. All right, so we've looked at the right angle triangle, equilateral, the scalene, isosceles, and the obtuse angle triangle, and the acute angle triangle. So knowing all of those, the CSEC would require you to know each of those, and bearing in mind the angles in a triangle add up to 180 degrees. You should also know that when we have a like this, for example, we have an interior angle here and an exterior. These two angles also add up to 180. And the exterior angle is the sum of these two angles here. Say we're calling this A and B and C and D. Okay, so A plus B would give you D. C plus D is 180. So once you know that, you'll be able to match angles, miss angles to find, and so on. Just know that these two angles are on a straight line, so they add up to give 180 degrees. So if you know this one, take 80 to find this one. If you know this one, D, take it from 180 to find C. Also know that this exterior angle is the sum of these two opposite interior angles. So if you know this and you know this, subtract A from D to E, subtract B from D to get A. All right, so you have to know all of those things. Next time we do trig, we're going to look at the angles, types of angles, not necessarily just for the triangle, but different types in general. All right, acute angles, angles on a straight line, reflex angles. That's what we're going to be looking at. The next step, trigonometry. All right, so this session, do your revision and practice, because that's what scholars do. Okay.